Alright guys, welcome back to Fix Lab, and my name is Fios, and today in this video I'm going to be showing you an interesting one, though it's just going to be a quick video because we're not going to be doing more of kind of complex code. So I'm going to be explaining this UI that I made. Alright, I just stumbled on Neumorphic UI, right, and I've been trying to see a way that can be done in Flutter, right? So and I stumbled on this package called clay container, right? And it seems to be what actually is very much close to implementing this kind of Neumorphic UI, which looks like more of a floating UI that you can actually touch. It looks like you can actually touch it. All right, so I saw that on Dribbble. There is a design by Muhammad Fadli on a calculator like this one, as you're seeing on the screen. You're going to find a link in the description to that design on Dribbble, and I was able to replicate some part of that calculator, and also using Getx. This tutorial, you're going to learn two things. You're going to learn how to build such UI, and you're also going to learn how to use Getx to actually, even though that is a simple calculator, but you are going to understand how to use Getx in a very clean way and be able to create reusable UI, and also separating of concerns, because your logic codes and business logic is totally going to be out in a different place. Your state is going to be totally in a different place, and you're going to handle everything just outside the UI logic. So everything is going to be seamless. To manipulate things, to change things is going to be different from what you've been doing before. All right, a lot of that. Let's just quickly get into it. But before we move on, let's try and see if this calculator really works. So I'm going to do 789 times 9, and let's see if that gives us 7101. So I'm going to pull up the calculator in this Mac. I'm probably just going to test if my calculator is fake. All right guys, so let's try that out. So what I did was 789 by 9, so it's 789 times 9, so we have 7101. So the calculator works, guys. So it makes sense that we can now continue, and then let's go through the code together and see how we did it actually. So first of all, I'm going to take you to the main, like I told you. But before I go there, let me go to the pubspec.yaml file. The pubspec.yaml file is where we actually put our dependencies, right? Just so in Flutter, if you're new to Flutter, this is where we put our dependencies. If you're coming from Android, this is actually going to be your build.gradle, where you put your dependencies. So the build level, the app level, build.gradle, where you put your dependencies, not the project level where you do your other stuffs. All right, so here we have clay container, which is what helps us to actually have this kind of look and feel. All right, and we have the Google font. The Google font is why we have this font that looks like a digit. So if I put 0, you can see you have this kind of look. So that's an Obitron font from the Google font, because I'm reading that from the server. Then have math expression. What math expression helps us to do is to actually convert the series of string that we have, to an expression that the computer can actually operate math on. So the math expression is a package that helps us to use the strings after we've formatted the strings, to make it a kind of precision ready type of expression that we can operate a mathematics on it. All right, so that's what the math expression package does. And then on the get is the Getx package, which has a lot of features really. So the Getx, but we're interested in the state management part of it and dependency injection. So we're going to inject our controller and be able to use them where we want it. So that's about this particular file, right? So it's not something very strange. You already know how to make use of this place. So let's go straight to the main.dat. The main.dat, you can see from my up here, you can see I'm calling get.put calculator controller. So if this is your first time, seeing this kind of thing, maybe you're new to Getx, this is how you actually call up your controller to use it. All right, so that the controller can be set up. All right, this is not the only way to do that, but because this is a one screen app, so we're not navigating from a particular location, if we're actually navigating from say splash screen before we get here, we could actually put our controller in a binding. That means we're supposed to have a binding class where we actually bind this. The binding is more like injecting this dependency. All right. So when you navigate to that place now, on setup of this screen, it pulls up this, and then you have get.put. We also have get.put lazy. Get.put actually makes this guy to become active immediately, and you can be able to access them. But get.put lazy, as the name sounds, is actually it's just hidden somehow. It only become active when you want to use it. So the app loads, my controller is active to start receiving events from the user, so that we don't have like null exceptions and stuff like that. And this is not the only place you can actually do this, but I just wanted to put it here so that it's easy for people to just see that, right? I can actually put that in my view, so that when my view is drawn on the screen before you start interacting, at least this guy should have been up. So that's it for that package. The theme part is already what you know, so I'm only injecting the Orbitron font into my base theme, which I'm actually passing to the theme field here in our app. And if you look again, you can see that I'm using, instead of material app, I'm using get material app. That's from the get package, so that I wrap all my widget inside the get material app, so that I can have access to all the stuff that get package actually gives. All right. So like I've said already, the Google font is the Orbitron font. That's what enables us to have this kind of font type or font face. And then we're using brightness, light brightness in this case. All right. So that's it for this. And then the next thing I need to look at is the constant. The constant is just where we define the colors and few of our paddings, right? So the base color is kind of a small shade of white with a little bit of brightness, right? Our secondary color is also this particular color, some shade of pink. All right. So this is the color we're going to be falling back on if we did not provide a color explicitly when we're defining our UI. And this clay container actually works in a way that it's more of like white and white. So your background is going to be white, and then the widget you're going to define is also going to be white. That is actually what is going to give you the lift of that field that you're looking for. All right, so that's about the constant. So let's go into the widget. So if you've actually followed our tutorial before, you must have seen how we build our reusable widget. So this is a button that we called car key button, and this is supposed to represent any of these individual buttons here. All right. So you can see how reusability really works. So what you're going to take away here is that you understand how to build reusable widget as well. Now you can see we have fields here is the child, and then the color, the callback. All right, the callback is going to list into tabs on each of these buttons. The color is going to be the color. The child is going to eventually be whatever we put here, which can actually be a text or an icon. All right. So and then inside that, wrapping our inkwell, as a child of our inkwell is the clay container, like I showed in the package. The clay container is actually what we're using to really show this effect of neumorphic look, right? So that's all for this. The child is whatever we provide here, which can actually be a text or an icon. As you can see, the icon exists here in this case. All right, so that's it for the button. Nothing special, something you already know how to handle. So let's go to the display. The display is our screen here. That's what displays our expression and result. So if you start out from the top, you can see that it takes expression input, and this expression input is a class I defined up here that takes two parameters, the expression string and the evaluated result. So the expression string is this string that you're seeing, and then the result is this result that we eventually evaluate from the expression. All right, so that's so that our result screen will accept a single object. And then in that object, when we define our design, just the normal thing, you know, these are clay container that represents this field you're looking at. And it has a depth of -25. That's why it looks a little bit of lifted. And then Bella range of 16, and also a base color like I showed you in the constant. Then we're using a curve type of none. Right. So, and then it has a height of a 150. Okay. So you can see if I decide to make it 120, you can see it's going to probably reduce. All right, can I leave it at 120? Okay, so that is that. And then I have a column. A column is where we are actually stacking this result with this expression with the result. So you can see here, I have the first one, expression.expression string, which is this. And then I have expression.evaluated result. But what we do is that we make sure that it's not empty. And then we can fall back an empty string so that we won't get an exception here. Okay, so that's it for this screen. And then you can see that our color for this result part is red. That's why you're seeing this red color down here. Okay, so that's it for this. You can see the UI part is not something very complex. It's something you're actually very used to. And that's what we have on this part of the widget. So let's take a look at the utils. The utils is basically some helper functions that we're actually using to keep things as we want, right? Let's start from the top. We have this expression, clean expression function that takes the expression, and when we say expression, this is what we mean, this kind of stuff. So we are saying if we have an extra garbage or operator that has no operand, we should be able to clean that up so that we don't get a bad or a failed mathematical operation on that. So you can see as this expression is 789 times 909, 9009 times 63 plus 3 times nothing. So this doesn't make sense in a mathematical sense. So we need to remove this. So this is what this expression is doing. So it checks if expression ends with any of this, which means there's no operand at the end. We need to remove that last stuff. That's what this guy is doing. But if everything is okay, like we have this, then it returns this expression because this is a clean expression. So that's what the cleaning does. So you see where we used it in our controller afterwards. So the color, get bg color, is what we're using to get the background color. So we are styling our operators and special symbols, special functions with a specific type of color, secondary color. So we are taking the label. When we check your label, if your label has any of this, then we'll give you this color, else we are giving you the base color. The same thing we are doing for the font color, right? So we want to give different shades of color to different shades of stuff, and that's what we're doing here, almost what we did above. So we give you this kind of black color, or we give you deep black color. All right, so that's what you have in our helper function, just 3 functions. So let's get into the more meat and bone of the tutorial, right? So let's go to the screens, and then inside the screen we have the calculator screen, and then it has about 4 different things. The index is just where we're exporting all the individual stuff. So you can see we have controller, state, and view, and we're putting in a library calculator. That's just for this. Let's look at the view. So the view is where just like I told you that we have it, even though this is a simple calculator, but we have a very organized code, and we're trying to be more of like, if this needs to be extended, it's easy to know where to look for something and make changes to that. So if you take a look at what we have here, you have a calculator state, and in this place we are trying to track the type of state that might actually happen in our calculator. So we have a result and we have an expression, and we'll have a way to expose them because this is private to this guy. So we have the get results to get mathematics expression. Then we'll have a set for the expression, we'll have a set for the result. All right. So this is just a pure barebone data class, if that's what we should call it. Okay? And then let's go to the controller. That's where the main thing happens. So in a controller now, we're extending our Getx controller, and once you extend a Getx controller, which is coming from the get packages, you have access to some kind of override functions. An example is this on init. So we also have on ready, and we have on start, and then different stuff like you would have if you're actually on Android, native Android, where if you extend, let's say, app compact activity, you have on create and on start and on stop and stuff like that. So Getx have some kind of stuff that we need to override and then do some stuffs. So this on init is before this guy is actually set up in the memory. So if you hover on this, you're going to see called immediately after the widget is allocated in the memory. So once this widget is allocated to memory, which is the widget that this guy is going to be controlling, we should do this. So what we're doing is that once this guy is being allocated, we need to clear out expression value to 0 and the result to 0 as well. All right. And then let's go back to the top. Then we have an expression. If you look, we have a multiple expression. If you've checked our state, you see that we have another expression there. The reason I had to do that is because maybe this is not the best way. You can actually put a suggestion on the comment section, right? Because we have a setter in the other place and we're doing a lot of appending in our expression. So to modify that other state is not very handy. So what I had to do was to have an internal expression here. All right, this set expression is not needed actually anyway. So but the get expression is just needed for me to be able to show out some stuff. So I have an internal expression which is also an observable, and you understand why we're using observable. So OBS is once you define a dynamic variable and you append it with .obs, it's going to automatically convert this string to an rx string. An rx string is a reactive string basically. So if it's of false, if this value is like false.obs, is automatically an rx bool. If it's an integer that I define here, maybe like equals 0.obs, it's going to be automatically an rx int. So these are type of variables that come from the Getx package that makes that particular value or variable to be reactive, right? Okay, so and then I'm actually getting the value, because if you do a Getx an rx string, the wrapper is the reactive thing. The value actually, the actual value, you have to extract it by using the value call to actually access that value. So right here, I'm actually extracting the value of this observable. So whatever it changes, I'm going to grab the value via this get function. All right. So that being said, let's go to the first function. You can see unequal pressed. Unequal pressed means that each time we type an expression and we'll click on this, we should do something. So you can see here, once we pass the expression, so these are the expression you typed. So we're passing it to unequal pressed. So we take this guy, like I said, let's say I have another stuff by the side. And then what are we trying to do here? So I do string cleaned operation, and I'm calling the clean expression. Cleaned expression is equals clean expression. And remember in our helper function, we saw this particular expression function that does the cleaning. So remove unused operators, just an example, 2 plus 3 plus 3 plus. It's going to give us 2 plus 3 plus 3 as a valid expression. So it cleans that out. But if there's none to clean, it returns the expression as is. Then after we've actually cleaned the expression, so we need to do a second step on it. String input is the input that we're going to now pass to our function, our math processor. So we now do cleaned expression, which is this guy. We assume it's being cleaned or it's okay. Then we need to replace this type of division with the one that the computer understands, which is this one. And then remove the x, which is the multiplication, with an asterisk, which is what the computer understands. And then we use our parser to really pass that expression. All right, so we're now calling expression, defining an object expression, and then we're using this parser, which will define an instance of it to pass it. So after it has passed it, then this becomes a kind of math-friendly expression from what our expression string is. That's why we don't really worry about the expression being a string, because you can't operate strings in normal sense. All right, so that's what this parser does. And then our result is eventually going to be an expression that evaluates, and we're using a particular model, which is the context model. The context model is just what this math package actually has. So it's a model you actually use. You need to pass it. Context model keeps track of all known variables and functions. So that's what it does in this case. So after everything has done, after you've clicked the result and we've done a series of stuff, and we evaluate that math expression, and we put it in this double evaluated, and then we're calling our state.results from our state stuff, and then we're updating it with the particular result that was updated. And remember that state is actually an observable and it's reactive. So that means everybody that listening to it is going to actually have the results updated. So if I go click on this, even though I have this division at the end, I'll still get a clean result. That's because it's going to remove this guy in the operation. It's not going to affect it. All right. Now, what else do I need to show you here? So that's on equal pressed. Remember, this is just the function definition. You have not seen where we're usually using it. We're going to use it in this place now where we're updating press states. So we're listening to whatever was pressed. So if C was pressed, which is this, all right? If C was pressed, we're going to remove the expression. We're going to remove both the expression and make it empty and the result to be 0. And then we're also updating our state.mat expression, which is in the state this time. Remember, there's this internal expression, but we're now also updating this one. Later, we'll be updating this one with the value of this. The reason is because we have this guy handy. We can do all the changes we want to do here, but we need to update this guy because this guy is what we need in the views. All right. So that being done, and then if you click on the C, like I said, the C is going to clean everything. Then the next thing we need to look at is this less than sign. This less than sign is what we're actually using on this place. If you go back to our, like you're going to see on our views, you'll see that this guy is the less than sign. We're using it to backspace. So what we're doing is our expression.value. We're saying get our expression.value, and we can actually make this more better because we are trying to not make this guy to be exposed. So let's just do a little bit of refactor. So we might not really need this get here. So let's comment the get and let's change where it was used. So to the same. All right, this can solve the problem. All right, this makes it impossible to access this particular one outside this class, outside the controller, right? So it will only be accessible via here, which is the math expression, which is being set up in the state. Okay, so what we're doing is get the value of expression that we have on the screen. All right, and if you tap on it, if you tap on this guy, we're going to get the length. So in this case, we have a length of 1, 2, 3. So get the length, start from this, the first one and minus 1 from it. So if I click on this, it's going to take the length of 3 and remove 1. That's what you have here, and then return that to be the expression, the current expression. So and then I'm going to update the math expression with the current expression, and that's what this does. This is where we do our calculation. So once the equal to is pressed, we are passing the state.getMath expression, which has been updated at this point. All right, we are passing it to this guy, and then it's going to use that expression to do the math operation like we've viewed on this equal pressed. So you can see how the controller thing works. Then if you're actually doing any of this guy, all right, that's why we needed to have a value we can manipulate. So if you press equal modulo, if I do 7 modulo, so we are appending our expression with whatever label that was pressed. So that's why we're having a series of string being updated. So if I do times, you can see this is an appending. So this math function, this math expression might not really work because we're using that function I showed you. You can see it doesn't evaluate to anything reasonable because it doesn't make any sense. You can't have modulo times together. So if you do this, you will have a result. Okay. So after we've incremented our stuff, we need to update the expression with whatever that is this guy at that point. So once we do plus, minus, times, divide, modulo, we update that. But once you do a default thing, which is like pressing the numbers, all right, then we also do this and also update our expression. So that's what this update press state does for us. So that's just the more meat and bone of this calculator stuff. You can see that everything about the calculator was handled inside the controller. But let's take a quick look at the view where we consume this guy. So here you can see where we're defining the button fields or the labels. So you can see we have C % less than, like I said, the less than is what represents the backspace, the division. You can see 7, 8, 9, X. You can see 4, 5, 6 minus 1, 2, 3, 4 plus 000 dot equals. So that's what we're using to form our keypad. And then these are all an arrays of strings for different rows. All right. Then how did we use that eventually? And if you check out this place, you can see that we're not using a stateful widget. Like I said before, the stateful widgets will make us do a lot of set states, and it's difficult to handle, and everything's going to look very messy. So we're using a get view, which is more like a stateless widget, but we're actually telling it that we're going to use a calculator controller, which is what we just get off from here. And then remember I told you that we're using OBS. If you remember in the controller that there's this OBS value attached to the variables, or even in our state as well. So that's why we're using OBX here to wrap our scaffold. In your case, in different applications, you might not really need to wrap the whole stuff. You could wrap the particular widget that you want to observe, all right? But in this case, I just want to observe that. I'm just being lazy, all right? So that at least I don't want to have one of my values not being observed and I can't be able to listen to that. So, but you can do that as well, all right? So assuming I just want to observe the screen, I could have wrapped the screen with OBX. All right, so that's it. So you check on this column, you can see the column is where we stack both the screen and the key parts. And then in this display result screen, which is our screen, it takes an expression input, which is the object that I showed you before, and then the result screen, right, takes expression, which is expression input, and the expression input takes the takes the evaluated result and the expression string. So how do we access those two information? We're accessing it from the state of controller.state.getResult. So we check if the result is 0, we don't return equal to with it. But if the result comes with something more than 0, we return is equal to. So that case would be if we have something like 0. Let's start afresh. We have 0 and we do equals. Okay, this is a different case. All right. But what I'm trying to say is that we want our result to have value that's bigger than 0. That's when we can actually show you. By default, if the app launches and you don't have a value that is bigger than 0, then we wouldn't show you equal sign. So if I do this times this, so we can have something like that. So in the expression string, we're getting controller.state.getMathExpression. Remember that we're updating our math expression each time we make a change to it. And because I told you that this is reactive, if you go to this very definition in the state, you can see that the math expression is OBS as well. That's why it's actually reactive and listens to whatever. Now, look at where we are building our buttons. You can see build button row. And we have like about 5 build button rows. And each one is taking those array of strings that will form our keypad labels. So then how do we do this? Let's look at the implementation of the build row. So down below we have this row that takes an array of string that is the labels, and inside that row is going through that particular list of strings, and then is creating a calculator button that has an on tap, and then it has a color. This is what we're using the helper function gets color with. I'm using the label to know what type of color we should show. And then on top, we're using controller.update press state. And remember, we're passing a label to it. If you go back to the controller, you go to the update press state, we're giving it a label. So that label is what is going to enable you to know what to do in this case. So if you go back and you tap the button, it's going to get the label of what was tapped, and it's used that to know what to do. All right. So this is very simple. But also everything is, you can see that in the screens here in the view, we don't have any logic, any implementation or business logic. Everything I see here is more of like UI related, and then trying to now interact with the controller part, which does manipulation of state and everything. So this purely MVC, if you would actually call that. So because we're able to manipulate our state using a controller and also be able to give that update to our screen. So in this place, like I told you, that's why we made our UI, this button, to take a child of widget, because we can either show an icon or we can show a text. So we're checking if the label is a less than sign, then we're going to return an icon that has a backspace. That's why you're seeing this. Else, we're going to return a text with that label, and then we're passing the font color to become get color from our helper function. And that's all that we did here, guys. And I hope you learned something from this. And if this is your first time to Fix Lab, don't forget to subscribe, turn on the notification bell, share this video if you like it, give it a thumbs up, because it's going to help to get other people to also see that this video might be helpful to them as well, and that in turn helps the channel to grow. So that means there's a lot of things that you're going to learn in the coming videos. So we're going to implement APIs ourselves, because sometimes you might not really have an open API to test some stuff that you want to do. So we might have to do that ourselves using Laravel or Java, Spring Boot. All right, and then we need to consume that with our Flutter app, right? So we are going to be hitting more state management and API calls in the subsequent video. So make sure you subscribe and make sure you join the Discord server, right? So a lot of things are going to be happening coming forward.